Hi guys, my name is Saumeel and we are Team 6. This is our final game demo for TopGear. We have created a 3D model game using Unity. The aim of this game is to implement at least 4 design patterns to our game and to make it user interactive. For this sprint, we made use of the Kanban board to keep track of our progress. For most part, we were able to complete the required tasks and the project was ready before the due date. As you can see, this is a class diagram. We were supposed to implement at least 4 design patterns and I have implemented the command pattern. Here, the invoker class calls the concrete command classes and the state of the command is saved as an instance in the invoker class. The command is determined during runtime. Next we come to the card modeling. To make the game interactive, it was very important to keep the card as realistic as possible. We made use of a basic card model and have added layers to it. As you can see, this helped us in giving a sporty look to the card. Meshes were applied to all the objects of the game, including the card, so that collisions can be detected. Different mesh was applied to the 4 wheels of the card to give a feel of drift. Um, we've also applied steering to the car, so we can use the arrow keys to accelerate and deaccelerate. Uh, Lastly, we've applied brakes to front and rear wheel of the car object, giving different car pedals to the front and rear wheel helps in giving the right torque and also helps in giving the car drift during motion. So this was all that we applied for car modeling.
Hi, I'm Wei Lin. Now I'm going to talk about UI wireframes. We created UI wireframes to understand what we will do for the card game. We made use of just-in-mind open source tool to make the wireframes. The card starts with a start screen, which will ask user to start or quit the game. As you can see, we included different types of collectibles that card can collect. Each of them gave different power to the card. We have made use of 3 collectibles. Health Kit, which will give player extra HP. Natural, which will increase the speed of the car. The last collectible is God Mode, which will make the car invincible. Another task that we worked on was sound effect and graphic user interface to display health meter and the speedometer. The design pattern worked on is strategy pattern. This pattern is used to implement view captured by the camera during the runtime. Player can get the view from both third-party perspective, which is outside the car, and also get the view from the driver perspective. Here is use case overview of the game. User can have many options at the beginning, like start or quit game. When game is on car is running on the road, it can collect several different collectibles like I mentioned before on the UI wireframe. These collectibles will affect either car speed or health points. The car can also accidentally run into lava, which may destroy the car and end game. If luckily, car reaches the destination with positive HP, player wins the game. Now I'm going to talk a bit more about each use case. The first one is called destroy the car. After car left the road and enter lava, it will lose HP. System will check its HP and destroy the car if the value of HP reach negative. You can see on the sequential diagram. When untouched event is called, the state of car will change and health points will get affected too. After that, health meter will get updated. The next use case is called end game. Game will end when car's HP is below 0 or when car arrives the destination. Here is the sequential diagram about end game use case. Next, Dennis will continue on the rest of use case. Thank you.
Hi, I'm Dennis. I'm gonna explain the REST use case and sequence diagrams. This use case explains what happened when car hit a collectible magic object. I will introduce the details in the sequence of the sequence diagram. This is the sequence diagram. There are two different patterns in this diagram. When the car hit a magic object, enter event of the car is triggered. According to different states, magic objects affect car differently and update the state of the car. After speed and health are changed, as observers, speedometer and health meter are notified to update the indications. This diagram is the use case when car encountered a health kit. It's a subcase of the first one. This is a sequence diagram. The following are the specifications of the 4 use cases. You can have a look at it. Okay, this is our class diagram. We implemented a state pattern to handle different behavior of car in different internal states. There are 4 states of car in our game: normal state, shared state, fly state, and nitro state. Each of them implements the state interface, which defines the general API exposed to public. Each state has different behavior and also handle magic objects differently, such as in shared state, car is immune to negative magic and can run in lava without losing any health. In nitro state, car get extra power and will run in double speed. And in fly state, car can fly over lava, across canyon and obstacles. By encapsulating different logic in different state implementations, we keep code clean and readable. In our recent game, terrain is a very important part. A good design of the terrain makes the game much more fun. So we designed and created different maps in our games, and each map is made of different terrains. This spiral terrain is an example of the terrain. We also have other terrains like mountains, plains, and canyons. This is the racing road. There are different collectible magic objects on this road. When you hit one, it will give positive or negative effect on your car. When you play the game, you have speedometer at the top left and a health meter at the top right. That helps you supervise the state of the car. When the health meter becomes 0, you lose the game. Okay, thank you.
Hi guys, I'm Shivang, and now I'll explain you the activity diagram of our game. Our game starts with the user pressing the start button. Then he can select a car of his choosing, modify it according to his wish. Then he can choose a map, and the game begins. The user then has to race through the tracks, and when he reaches the destination, the corresponding result is shown, and the game can either be restarted or can be quit. Now this is the class diagram, and in this game I have implemented the observer pattern. In that, the subject of this pattern was car, and the observers are the health and speed meter. So depending on the values of the car, the health and speed meter value changes. This was done using fixed update method in the car object. Next, we come to the physics of the car. We can control the car using arrow keys. So as you can see, when I press left or right arrow, the car takes the left or right turn according to the movement of the wheels. We have also calculated the torque of the car based on the movements of the wheels. Also, we have applied gravity to each and every object in our game so as to give a realistic feel to the player. So as you can see, the car will take a turn or bounce off accordingly. Also, we have implemented lava on our terrain. So when the car is in touch with lava, the health of the car reduces. So when I get back to the road, the reduction in health stops, and when I touch the lava again, the health reduces. So this is our game. Now I'll leave you with the complete demo of our game. Hope you guys enjoy it. Thank you.